What's up YouTube, this is Demkeys back again with another Unity tutorial, and today I'm going to teach you about AI. What is AI? AI stands for Artificial Intelligence. AI is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. Some of the activities that computers with AI are designed for include speech recognition, learning, planning, problem solving, etc. By the way, I just read this on some site. Now, in the case of games, AI would be useful in cases where we want the enemy to be able to think on its own. It doesn't apply only to enemies in the game. You might also need AI if you have NPCs or non-playable characters, so that they can interact with the player. There are many uses of AI. To demonstrate an example, we are going to write some simple AI logic that will make the enemy follow the player and eventually shoot the player. This is going to be a very basic tutorial to give you an idea of how AI works and how you can add AI to your game. So let's begin. What we have on our scene is a plane and some lights. We need to add our player and enemy. I will be using the first person controller from the standard character controller package. You can import the package into your project like this. Right click in the project panel, click import package and select character controller. Then you'll have this box open up over here, and you just leave everything selected and click import. I've already imported it, so I'm not going to import again. Okay, so let's add the character. Okay, that's fine. Next we need to add the enemy. This will be a normal capsule, and we will name this as enemy. Let's resize it a little bit. And let's also add a head to the enemy so that we know which direction the enemy is actually looking in. Now, some of you may be wondering how can you make sure that you are actually placing the head in whatever direction is considered forward by the capsule. Oh, sorry, I forgot to rename this object. Yeah, so some of you might be wondering how you can make sure that you're placing the head in the right sorry. Okay, I'm not going to repeat that sentence again. Um, so this is how you do it. You will notice a blue arrow over here. Just make sure you place it in that direction, like this, for example. You can see the blue arrow is facing this way, so you place the head like this. You can also see the capsule's blue arrow is that way, because transform.forward usually looks only at the blue axis. That's how it calculates what is forward. So based on the rotation of our object, the head is also going to turn with the enemy, and that is how we will know exactly where the enemy is looking. Okay, what do we do next? Next we need to add a new script to our enemy game object. We'll call this enemy AI script. You can, oh sorry, I already have one such script created. I've kept that script just for reference purpose in case I forget anything. So I just added 01 at the end of the name. That's okay, you can name the script whatever you want. So the first thing we need to create is a public transform variable, and we will call this, just a minute. Yeah, we will call this player. Next, we'll create a public float and call this player distance. Next, we need okay, let me show you something before we continue. Okay, let's set the value for player distance. The value for player distance should be player dot position minus transform dot position. I'm sorry, I'm having some trouble remembering the script. I need to look at it again. But yeah, so we have added these few lines of code. This is to show you how you can calculate the distance. Oh, I'm sorry. I wrote the wrong line. What we need is vector3 dot distance. I am very sorry, I'm having some trouble concentrating. Okay, so we want the distance from our player. What does this require? Vector3. Okay, so from player dot position to transform dot position. Okay, now since this is a public float variable, we should be able to see it in our inspector. Let me change the layout. Alright, so before I run the game, now we created a transform variable called player. This is so that we can actually, well, it's so that we can do this. I'm sorry, I wasn't able to explain that. But yeah, after doing this, the code is going to access player.position. So basically it's going to access this this object's position. Let me select this again, and now keep looking at player distance. I'm going to play the game. You can see as I move backwards, the distance increases. As I move more closer, the distance decreases. Okay. Next. Next, we need to add a line of code. We need to add an if condition saying if player distance, sorry about that, my alarm clock is ringing. Okay, so if player distance is less than 15f, I think 15f should be enough. Then look at player. Okay, so then we will call look at player. Now what comes under look at player? First of all, we need to create a quaternion and call this rotation. This will be equal to quaternion dot look rotation, and I believe it is player dot position minus transform dot position. Just let me make sure I'm writing correct. Okay. Next. Alright, let me explain what look rotation is. I cannot explain look rotation properly. Just know that it's going to return a quaternion, which is basically the rotation, and you require to do it in this way because when it comes to rotation, the calculations are slightly different. You don't just enter values and start rotating the object. It works in a different way. So you require this for our next step. That will be transform dot rotation equals quaternion dot slurp. Quaternion dot slurp is going to start, it's going to rotate the object from one point to another in a given amount of time. So you can either make it as fast or as slow as possible. It's basically another way of smooth rotation. So from transform dot rotation to rotation. The rotation has been calculated in this line. Next, the time. Okay, for the time, we'll add one more variable and call this rotation damping. And we can set the value from the inspector later. So the time will be time dot delta time. This time dot delta time, whenever you use it, it is basically a way of making your game frame rate independent. You won't be depending on the frame rate of the game to set whatever you're doing, like call methods or do anything. You won't be depending on the frames because the frame rate in different PCs can be different. If it's a really powerful PC, the frame rate will be really high, and if it's a very weak PC, then the frame rate will be really low. And in that case, your game's performance is gonna be different. So time dot delta time basically makes your game frame rate independent. Okay, time dot delta time into rotation damping. So as I mentioned before, quaternion dot slurp is going to rotate the object from one point to another in a given amount of time. We can specify the time, and we have already done that. Now let's see if this script works or not. Let's reposition the player. First rotate, make sure the player's okay. So let's position our player over here. Actually no, let's position him a little more further and change his rotation so he's looking at the enemy, but as you can see, the enemy is not looking at him because the head is pointing in a different direction. So next we need to add some damping. Now damping, how it works in this case would be, just a minute. Yeah, how it works in this case would be, if you set the value high, then the rotation will happen very fast. If you set the value low, the rotation will be slow and kind of smooth. Depending on what you're using it for, you can set the value accordingly. I am going to set it to, first let me set it to 3 so I can show you the rotation going slow. I'm going to play the game now. Okay, I need to place the player more far. Alright, so it was still too close. Let's make the player even more far and select the enemy so you can actually see the rotation happening. Okay, so currently the enemy is looking the other way because the distance, as you can see in the inspector, is 19. So let's move closer. As you can see, the enemy has looked towards our player. Now let's go to another side and come closer from there. So now you can see how the rotation is happening. Let me increase this to, let's say, 10. Now the rotation should be quite fast. Yep, it's just fine. Okay, so next. Alright, this was for just looking at the player. Next, we need to add a public float and call it chase range, or let's say chase start range. Actually, I don't think we need this variable, but yeah, no need. Let's just check if player distance is less than 12f. What to do then? So we'll create another function called chase, and chase will be called when our player distance is less than 12f. Okay, in this function what do we need? We need transform.translate vector3.forward into time.delta time. Now because we want to be able to set the speed of the enemy, let's add a variable and call it move speed, a float, public float variable, and call it move speed. So it will be vector3.forward into move speed into time.delta time. So what this is going to do is it's going to move our enemy in a forward direction, whatever is considered forward by the enemy, at a speed of move speed multiplied by delta time. I hope that makes sense. Let's see if this works. Before that, let me set the speed of our player. No, sorry, the enemy. Oh, and also, let me show you how the enemy is rotating. The enemy actually rotates as, oh, I went too close. Okay, anyways, so yeah, you can see the enemy is rotating and following our player, and this only continues as long as player distance is less than 15f or less than 15. As soon as it becomes more than 15, which as you can see here is 17 currently, the enemy stops following us. Oh, sorry, the chase continues as long as the distance is less than 12f. But the rotation, that means basically looking at our player, the enemy continues to look at our player as long as player distance is less than 15f. Once we increase the distance more than 15f, the enemy is not looking at our player. If we come in from this side, you can still see the enemy is looking in another direction. Now it turned its head. Okay, now well, there are a lot of bugs in this logic because it's a very basic logic. One of the bugs would be our enemy doesn't know when to stop. So here's what happens. As soon as the enemy collides with our player, it starts spinning. To stop this, we can add another if statement over here saying if player distance is more than 2f. Yeah, if player distance is more than 2f, then continue the chase. Now let's see whether this works or not. I'm not going to run from the enemy. I'm going to just stand there. It works. Our enemy has stopped. Alright, now this is okay. The enemy is chasing our player. It's even looking at our player when we reach to a certain distance. After the enemy is done chasing the player and gets close enough, sorry, I shouldn't have used is done. I mean, once the enemy gets close enough to the player, we want the enemy to attack. So for that, we will create another function and call it attack. And attack will be called over here. After the if statement, add an else if. So else if player distance is less than 2f, then we want our enemy to attack. Okay, so for this we will use physics.raycast. Let's first create a raycast hit variable, and then if physics.raycast transform.position, that is where the ray will be cast from, and next I believe is the direction. Yeah, next the direction would be transform dot forward, and next we need to add an out parameter. So basically this is where our raycasts information will go. That's it. Yeah, no need to add the distance. Okay, within the if condition we create one more if condition to check whether the object that has been hit has the player tag on it or not. To do that, we'll write if hit.collider.gameObject.tag equals player. What do we want to do next? Now before we continue, let's add a script to our player. We can call this health script 01. Okay, here we'll create first of all a public float health, Next, public static bool is player alive. Currently, that is true. Okay, if health, oh sorry, so next we have to add an if condition to our update function and say if health is less than 0f, then destroy game object. So since we have attached this health script to our player, as soon as the player's health goes below 0, the player is going to get destroyed. So what do we want to set over here? hit.collider.gameObject.getComponent health script o1 dot health minus equals 5f. Okay, I think we can test this script now. Before we start, before I play the game, I have to add the player tag to our player. So the enemy is approaching our player. I'm going to try and run from the enemy a little bit. As you can see, the moment the distance went below 2f, the enemy attacked. And the reason why you didn't notice the health going down slowly was because it happened really fast. I haven't set a timer for the attack, so the attack happened, I guess, one frame after the other. Maybe I'm saying that wrong, but whatever, it happened really fast, and so it reached below 0 really fast. We have an error over here. This says the object of type transform has been destroyed, but you are still trying to access it. The reason is the update function on our enemy script is still being called, and the sorry, yeah, the update function on our enemy script is still being called, and this line is trying to access player.position. Player.position, if you remember, is a public transform which was accessing the player object, this object. Now since this object has been destroyed, at the next frame or at the next update call, when this line will execute, it will definitely give you an error. So we don't want any of these lines to execute if the player has been destroyed. So we create an if condition and check if health script o1 dot is player active, no, is player alive, sorry, and just put all this stuff within that if condition. I'm doing something wrong here. Just a minute. I forgot where is player alive should go. Oh, okay. Is player alive should go here. Alright. So sorry about that. This line should be here in our enemy AI script, and then before our object is destroyed, or I guess even after is okay, but yeah, let's add it before and see. If health is less than 0, then enemy dot enemy AI script o1 dot is player alive is equal to false. And then from that point on, whenever update is called, none of this is going to execute. Let's see if this works. I have an error. Oh, sorry, I forgot to change it over here, because now is player alive is currently on our enemy AI script. Alright, so let's go close to the enemy. The enemy starts following. We run around a little bit. There you go. Our player has been destroyed by the enemy, and we are not getting an error over here either. So that's it. I hope this tutorial was helpful. Check out these other videos as well. The video on the top left teaches you how to use the interactive cloth. The video on the top right shows you some simple level design. And the video on the bottom left corner teaches you how to use Unity's mechanism system. Visit my channel for more videos. Don't forget to like, share and subscribe. Leave your comments below, and I'll see you guys next time.
Is he saying names? Is he grow? Is he fame? Is he even still the same? Claiming Lord's boys, but we never seen him main. Not on cover, now on album when he get the chance to hang. Like, damn, 1 3 4. Niggas acting like I never been through them doors.